All right, as you're getting your notes out, quick reminder, grades for like JMC and stuff will be updated for you guys tonight. I'm on to your guys' class next, so it'll be updated tonight. So you'll see all the stuff we've done doing the last week put in the grade book for you guys. You can kind of see how it's affecting your grade. It doesn't. Some of the stuff we've done doesn't affect too much because like the in-class activities stuff we did is only worth a few points, but some of the bigger worksheets could affect you pretty good. Semester test, because every class has to have a semester test. We are going to have one. It will be after winter break. It's going to be the Tuesday after. Now, the reason why I'm doing that is I have to. The reason why we're doing that is because I've been gone. Like, I don't know if I'll be back this Wednesday or Thursday. That's what I'm hoping for. I still want to do a 5-day review leading up to it. So, like, I want to do a review, you know, if I'm back Thursday, Friday, Monday, Tuesday, Wednesday of next week. And that way when we're back the following, you know, after winter break, we can use Monday as like a quick review to go over any problems you possibly forgot if you didn't watch the videos over break. Because I'll post the videos right away so you can watch those videos like over and over and over and over and over until you understand it. And then on Tuesday when we're back, we'll take it. The reason being is I looked at the semester testing schedule because they sent it out last week and I didn't get it because I wasn't there. You have a lot of semester tests coming up this week and next week. Like, there is a lot of tests. Yeah, no joke. They're already starting today, and I didn't know about it until I saw it this morning. And when they sent me an email like, hey, you should get your tests on there, I'm like, oh, thanks for telling me. I haven't been there. So I looked, and the only day that didn't have tests was the Tuesday we're back. It was like there was no test that day. So I'm like, all right, I'm putting my test that day so that no other class or no other kid can complain that there's like 100 tests. Because if I would have put it like next week, Monday and Tuesday, like I was kind of thinking of for next week, there was 15 tests those days from the different sections so that I could see. So like some kids could literally have 8 tests all day. Like every class could have a test. So I didn't want to do that to you. So I put mine on Tuesday. I know it's not convenient, but it does give you a little bit extra time to watch those videos like over and over and over and over. And plus, if over break, if you need to go over some questions with me, because I know some of you have sent some emails to me like, hey, I'm not really getting some of this stuff. Maybe over break you can Zoom with me a little bit and kind of figure it out. So, but yeah, so I'm trying to give you a little bit of time since I haven't been there. Now I'm lowering the semester test for me down to 10%. It's not going to be 20% like normal. The reason why is I haven't been there. So I feel kind of bad, but I have to have one. So I'm putting it at the bare minimum that it could be. So I'm gonna probably send out a parent email probably tomorrow, kind of warning parents of like, hey, this is my semester test day for my classes. This is what it's worth in the grade book, just so that they're well aware of it. Because I want to be kind of upfront and so that you guys are aware when it is, what it's going to be worth on your grade. So. But I want to be fair too. So, all right. So let's go through a couple things here. Let's go through some notes. I only have a few problems I want to get through, 3 or 4 problems I want to kind of walk through today, and then we're going to kind of end with a doozy, so we can actually see it. But yeah. So I want to kind of review some stuff with you here. So, yeah, let's kind of walk through here. As you can see, kind of it's the same kind of outline we've been using the last couple days, but we have some stuff to kind of review because I think that's what it's going to come down to. That people that are going to be successful at this unit is, do you just remember the little details? Do you remember, not only just what are the derivatives, what is derivative sine or cosine or natural number or some number to a power or the chain rule or product rule. Can you remember the rules and like use them together? And I think that's what people are getting hooked on. They're getting stumped on. Like, what do you do next, right? Because you don't know the rules as solid as maybe I would because I've been practicing it for 15, 16 years. So, but let's kind of walk through some of this stuff here. Let's kind of walk through one of our first examples. What I want to talk about here just in general is just kind of how to prove something. So I want to talk about, why a certain thing ends up the way that it does. So what I mean by that is I want to show why do you get a derivative of, like, what happens when you take the derivative of x to the half? I want to talk about, like, why does it work out to be a certain number that it does? So this is going to be my first example. I think I got like 4 that I want to pick. So I'm going to do this one. I'm going to do a natural number, like e. I'll do another number. Maybe I'll do like a to the x, and then we'll do a kind of a doozy at the very end. So, all right. All right. I want to explain how to find the derivative of this thing. Now let's just talk about the rule. So we do. This is a normal power rule. Okay. So we're going to start with something easy here. So if I'm going to take the first derivative, just normal power rule, what do? Somebody walk me through it.
Power up front.
Drop the power out front. Good.
Minus 1.
Yeah. You take the power and you subtract 1 off of it. Does everyone understand that? That's the normal rule. Now, what this is going to end up being, if we do this correctly, it's going to end up being this. It's going to end up being 1/2 x to the negative half power. Now, the reason why it ends up being half is because I'm taking and I'm subtracting 1/2 and subtracting 1 off of it. So when you actually subtract that in the power, right, this is the power right here, you have to make this a fraction, so it's 1/1. And then to make 1/1 like the same denominator, you make it 2/2. So that has the same denominator, because you have to have the same denominators before you subtract straight across. Well, when you subtract straight across, you just subtract the top. And that's why it ends up being what it is. 1 minus 2/2. That's how you add and subtract fractions, right? You get common denominators, you just add or subtract the top. That's all you do. That's why it ends up being that. Now, when we simplify that mess, maybe I should take a screenshot of that. All right. What that ends up being, if we were to simplify this out, it means this. It would move this x to the half to the bottom of your fraction, and the 2 that was here is still on the bottom of the fraction, if that makes any sense. The 2 is still on the bottom. The x to the negative half power moved to the bottom and now became a positive half because it's on the right side of the fraction now. And what does it mean to be a half power?
Square root.
Yeah, square root. So this is really what we're looking at. This is the same problem, right? Oh, sorry. That should be an x, sorry. All right. Yeah. Okay. Does that make sense right now?
Does this make sense? Yes.
Okay, I'm going to take that as a yes. All right, now let's discuss why. I want to get to that today. Like, how did we know that it ends up being this? Because that seems like a very weird thing. Like, how do you know that the x will move to the bottom? How do you know that there's going to be a 2 down there? Because you're just trusting that the power rule is going to spit this out, right? So that's what I want to talk about today. Like, how do we know that it's going to get to this point? So that's what I want to discuss. I'm going to try to explain this as best I can, and it can be kind of tricky. Okay, so I want you just to follow along here. Now, this proof is a definitive proof. This is a proof that every textbook has. This is a proof that I remember my calc professor going through to explain why this works. And I think that's what you guys just need to see sometimes. You just need to see that proof. Where did it come from? How did they get to that? How do they know? Other than doing the long, or doing that differential quotient. I don't want to do that. Okay? All right. So let's talk about it. Okay, so let's say, so this original function is x to the half, or it's the same thing as the square root of x. It's the same thing. That's my original function, right? I'm going to draw a line. All right. If I were to square this thing, if I were to take this function and square it, what would happen? Yeah, exactly right. The square root symbol would go away, right? Because you'd actually be squaring a square root, which is the inverse operation, right? It's the complete opposite. Square and a square root, they're opposites operations, and this would cancel, and you'd be left with x. You're absolutely right. Okay, so now I'm going to explain here just in a few seconds why they do this. This is the definitive proof. This is what every textbook does to prove this thing. Okay? And hopefully this will make sense to you as we go. Okay? Alright. Alright, so what they do to explain this, they're going to take the derivative of both sides of this thing. So I'm going to start here. I'm going to take the derivative of both sides, and I'm going to show what the derivative eventually molds into. Okay? Alright. So if I were to take the derivative of this side right over here, this thing, what do we normally do in terms of chain rule? What do we do?
Drop the 2 out front.
Drop the 2 out front. Then what?
Subtract 1.
Subtract 1. Good. And what?
Times by the derivative of the inside.
Derivative of the inside. Okay. And on the other side, so that's good. That's the chain rule, right? You drop the 2 out front, you subtract it off the top, and then you take it, whatever the inside is, you have to take it times the derivative of the inside. That's normal chain rule, right? Because that's how we do it when there's a power of 2. I just don't know what the inside is. Okay? And so now on the other side of the equal sign, so now we're over here. What is the derivative of x?
1.
1. Okay. Perfect. We're done there. And what I'm going to do is I'm going to solve for f prime of x. So that's the first derivative, right? So these are being multiplied together. This is being multiplied onto this thing. So to get rid of this side right here, what is the opposite operation of multiplying?
Divide.
Divide. I'm going to divide both sides, or just technically divide this over. So if I do that, here's what I'm left with. I'm left with 1 divided by 2, and in parentheses, f of x, and then the power is 2 minus 1, which ends up being just a 1 for a power. Does that make sense? Okay, and then what I'm going to do is I'm going to substitute back in what f of x is. Well, f of x originally, on my original problem, was this. So I can either put x to the half or the square root of x. I can plug whatever I want in there, but I'm going to plug it back in, and this is what I'm left with. I'm left with, in parentheses, x to the half, and that's to the first power, which I don't actually need the 1 on it, and I don't actually need the parentheses on it because it's already, it's already accounted for. And that is what the first derivative is. That's the first derivative of my f of x, which actually proves this mess that I just showed you up here. All right. Now, I know that may not help you. Maybe it will. It's one of those things that sometimes it's just kind of nice to see how did they come up with something. How do we know that it ends up being this derivative? Now, the reason why I picked this problem in particular is because, number one, it's a nice review of how to do chain rule, right? We had to do chain rule in this problem. And then it also reviews how to do radicals, because we haven't seen that type of stuff. So that's in this section, this unit, this section, what are we in, unit 4? It's this derivative, section 3.4. It just talks about random derivatives, like radicals. It talks about the trig functions. It talks about other, e, and it talks about all those derivatives. So this is just one of those things that I think it's kind of important you get to see some of these sometimes, that you get to see why does the derivative turn out to be a certain number that it does. Why did the power rule work the way that it did on this one? Sometimes it's nice to see the proof of it. All right, questions on this first one? Okay, if you were doing a homework problem or a test question, I would expect to see this stuff, this stuff up here. Right, where you just do the normal power rule, like the quick way of doing it. That's what I expect to see. I don't expect you to do a proof like I'm doing. No one would understand how that works. I just want to show you why certain things work out the way that they do today, so that maybe that'll clear up some of your confusion on some cases. I don't know. Hopefully, I'm not confusing you even further. I'm hoping I'm not. So, all right, let's do another one. Let's do another one here. Let's do like e to the x. Let's do that. Okay. Let's do e to the x. Okay. All right. I think I've done this proof before, but I just want to kind of walk you through it. The derivative of e to the x. Okay. What? Yeah. Somebody said it?
It's just e to the x.
Good. It's just e to the x. All right. Now, let's talk about y. Okay? Because you're right. It is just e to the x. Let's talk about y. Here's what it is. Okay? The first derivative. Again, I'm going to draw a line here because we're just kind of showing why it works out the way that it does. The first derivative. It is actually based on the rule for the natural log number. Some number to a power. We're going to go through that here in a minute. That's what my next example is. It is whatever your base number is, because this is a digit, right? E is just a number. It's 2.7, but it's some digit, right? Well, what you're supposed to do is take the natural log of whatever that base is, times whatever your original function was, times the derivative of the power. Well, what's the derivative of x? 1, right? Because you drop the power up front, subtract 1 off the power, so it'd just be a 1 out front, because x to the 0 would drop out. And this is the rule. This is the idea of what they did. It's using that natural log, and I'll show you that in the next example we do. Well, the natural log of e, this means log base e of e. That's what this part in the parentheses stands for. So what a logarithm is, if you don't remember from pre-calc days, it's what power do you put on e that makes e? What power would you put on it? 1. So this whole thing is just a 1. So it's 1 times e to the x times 1, and that's why it ends up being just e to the x. That's the reason. Now, maybe that confused you a little bit. I'm going to do it on the next example, showing you with other numbers other than e, just so you can see what that derivative is. And then we're going to prove it. Okay? All right. So, let's do it with a weird number. Let's do it with like, yeah. Okay, I think I heard 10. I think I heard 10. Okay, 10 to the, let's just go 10 to the x. Okay, let's do something simple. I can put something more complicated here in a second. All right, so since this is just a random digit, right? It's just a random number. When you take the first derivative of it, since it's not e, you don't just put the same thing down. You'd have to do the natural log of whatever the base number is times the original function times the power. That's the derivative of the power. It's a chain rule, right? So the derivative of x, which is 1. And so this problem ends up just being natural log of 10 times 10 to the x. And that's what we talked about a long time ago. That was like Unit 2 for us when we started doing derivatives for the first time. This process explains why e to the x works the way that it does, because it's using this rule. It's using the rule of exponentials to do it, and it's a chain rule. So that's why I'm trying to. If you haven't noticed, every problem I've been doing today has been a chain rule. I'm trying to show you that. All right. Questions at all about the natural number, like the natural log, like when we introduce that?
What's the answer to that one?
This. Okay. Now let's talk about something else that we have not discussed. This will be a brand new problem. So this is something that you have not seen before. So, okay, so this is a new problem.
It's a problem. I sure hope so.
All right. This is the natural log of x. It's not x to some power or anything like that. This is my original function. And I want to take the derivative of it, which is something we have never attempted. Okay? So, I'm going to just show you what it is, just the shortcut. And then we're going to talk about how does it get there. Okay? So I'm going to do a proof of it. Okay, so whatever you have, so whatever that item is in the parenthesis, right? I just put X here, but it could be anything. It could be any weird, crazy thing you want to put. This is how it works. When you take the first derivative of this mess, it will end up being 1 over whatever is in the parenthesis, right? X in my case. And then you're going to multiply it by whatever the derivative of the parenthesis is. So whatever, it's like a chain rule, right? So what is the derivative inside the parenthesis? So what's the derivative of X? 1. And so the answer for this thing ends up just being 1 over X. That's the first derivative. That's it. That's the answer. That we've never done that before. We've never taken a derivative of just the natural log of, something, right? X in this case. I want to show why. I want to show why does this actually even work. It's kind of a weird concept. All right, to do that, we have to acknowledge what these are, okay? And we have to kind of show this. This will not be easy. This actually could be pretty confusing. So I'm hoping that this will make sense to you. No, you can just kind of watch if you want. All right. So.
Watch quietly.
All right. So. How this works is you need to know a property from pre-calc days. So here's the property I want you to understand before we begin. So property. It is e to the natural log of x. Okay. What this is e to the natural log, so it's log of base e of x. Right? Because that's what the natural log stands for. This thing stands for this. Well, what happens when you raise something to a power that's the inverse, right? These are inverses of each other. Log of e and e are inverses. These cancel out, and you're left with x. They're just opposites of each other. They just undo each other. It's like power of 2 and a square root. They just undo each other in your back. Or it's like adding a number and subtracting the same number off of it, and you're back to where you started. Or you're multiplying by a number and you divide it by the same number again, and you're just right back to where you began. That's what we're doing here. You need to understand that property. It works for anything. So if I did, 7 log base 7 of 2, the answer would just be 2, right? These things cancel each other out. They undo each other. That's the idea. Okay, do we understand that basic property? All right. Now, let's get to the real proof here. Okay, so let's talk about how to find the derivative. All right, so I'm going to try to prove this derivative is this. Okay? Does that make sense? But I'm going to use this property we learned in pre-calc to do it. This is a proof they have in almost every single pre-calc textbook. So just be kind of aware of that. All right, so how they do it. It's using chain rule. That's kind of the theme of today if you haven't got that. So, taking the derivative. So I'm going to take the derivative of this side, right? So derivative with respect to x of e to the natural log of x. And on the other side, same thing, I'm going to take the derivative of this side. That's the notation for taking derivatives if you don't have like f of x and you can't put a little prime symbol. Okay, so derivative. Well, what is the derivative of e? E, right? It's e to whatever it is, right? So it would just be e to this. And then you have to multiply by whatever the power is, right? The derivative of the power. It's a chain rule, right? So I don't know what the natural log of x is. That's what we're trying to show. I don't know what this is. So this will just be the derivative of this thing. I don't know what that is. That's the power, right? I got to take the derivative of whatever the power is, and that's what I'm trying to show you. I want to prove that the answer for the natural log of x is just 1 over x. Okay? So that's just, all I've done so far is just this side of the equal sign. That's this part right here. It's just chain rule. Derivative of e is e, and then if there's something weird in the power like we had, we have to take the derivative of that thing, which I'm trying to show you what it is. And what is derivative of x on the other side? 1. Okay. So, we've taken the derivative of e, we dropped it out front. We have the derivative of the power, which I don't know what the derivative of the power is. That's what I'm trying to show you. And we have the 1 on the other side. Okay, what I'm going to do is I'm going to solve here. I'm going to just get this thing by itself. So this is being multiplied, so how do I get rid of this to the other side? What do I have to do? Divide. Okay, so the derivative of the natural log of x. This is what I want to show you. This is the whole point of today. I don't know why I wrote that so small. Natural log of x. Alright, I want to... Just let me write that x. Come on, there we go. Alright, the derivative of the natural log, if I divided the e to the natural log of x over, it's e to the natural log of x over, right? I divided that across to the other side with the 1. Okay, so we divided it over, and what is this thing equal to? This part right here. X.
And then it's the same.
The derivative of that, of natural log of x, is 1 over x. I'm just showing you the definitive proof why it always works out that way. Okay. Alright, we have one last problem today, and then we're going to be done here. One last thing. One last derivative. And it's based on this one. It's based on chain rule. So we're going to put something kind of goofy in the power. Or goofy in that x location. Alright, is everyone good with this? Can I move on?
You asked a question.
Yeah, we're good.
Okay, moving on. Alright. Last problem of the day. Here we go. So the absolute last problem. Derivative. Okay, natural log x cubed plus 2x squared minus 5x. Alright, so this is my function, right? It's based on what we just learned a little bit ago. We're going to take the first derivative of it. Okay, so first derivative of a natural log. Well, what we just learned about is that what you're supposed to do for the natural log here is it's 1 over whatever it's in the parentheses, right? And that's what we just learned. So it's 1 over this mess right here. Then we have to multiply by whatever, because this is chain rule, right? We have to multiply by whatever the derivative inside the parenthesis is. Alright, so what's the derivative inside the parenthesis?
X squared plus 4x minus 5.
Minus 5. Okay, and your final answer, that is correct. The final answer is I just have to multiply that mess to the top. Because when you multiply by fractions, this just multiplies to the top because there's a 1 technically on the bottom. Right? So this will end up being this. 3x squared plus 4x minus 5 all over x cubed plus 2x squared minus 5x. And that is your first derivative simplified. That's my last problem of the day. Alright, tomorrow we're going to continue on with some of this stuff. We're going to move on, we're going to do some more properties. We're going to look at the trig functions like tangent and cosine and sine. We're going to review some of that. We'll do some more product rule, some more quotient rule tomorrow. So today was about chain rule. That was kind of what I wanted to focus on today. So we'll look at some of those other properties tomorrow. So just be kind of ready to go. I'm going to kind of do a little bit of review every now and then with this stuff because I know some people are still kind of confused with the difficulty of the problems we've been working on because they've been tough. I know they have. So we're going to kind of get through that. Gradebook for you guys will be updated tonight. I'm going to put in the stuff from last week and stuff. So gradebook and missing assignments and whatnot, they'll be entered. If something looks wrong or maybe you emailed me an assignment and I forgot to look at my email, just let me know. But yeah, gradebook for you guys will be updated tonight, and then tomorrow you can kind of see if there's anything you're missing that you need to turn in. You probably can see that right now in Google Classroom. You can go into your classroom and see that, oh, hey, I haven't turned in 3 assignments, because it tells you have missing assignments. So you need to go get those submitted. But yeah, I'll be back hopefully Wednesday or Thursday. Thursday for sure. I don't know if they'll let me back Wednesday. I don't know. I don't know if that's my 10-day. I think it should be. Okay. But that's it for today. I know that some of you have expressed some concerns and stuff. We'll get some of your questions answered. So just be ready to go. We're going to keep it kind of easy until I'm back, and then I'll start reviewing for the semester test. Any questions before I go?
No.
Perfect. All right. Have a good one, guys.
Lord.
Later, guys.